Hi everyone, this is Pure Maths and we are looking at circles. But first, we are starting with midpoints and perpendicular bisectors of a line segment before we go into the theorems of circles. When you do geometry, all those things you study about segments of a circle, the chord, all those theorems. But we'll start from midpoints. So what is a midpoint of a line segment? If you have this graph here, you can see this is y and this is x. And you are given 2 points on this line, A and I and B, points A and point B. You are asked to find the midpoints of this line segment, of these two positions, A and B. More or less, you want to find the middle points or the midpoints of that line. How do you go about that? The way you do it is just like finding averages of the coordinates points. If you now want to find the midpoints of AB, midpoint AB, this will be, you will find the x ordinate, that is x1 plus x2 all over 2. You divide, you find the average, and then the y coordinates, you find y1 plus y2, find the average, and this is your midpoint. This point here, this is your midpoint, or these are your midpoints. These positions, this line segment. So, what about the perpendicular bisector? Say now you have a line. You find your midpoints, say the position of this point is here, for example, is here. Then you want to find the perpendicular bisector of a line that passes through this point. Say now you are looking at a line like this. When we say perpendicular bisector, it means it cuts this line at an angle of 90 degrees. Correct? I will name this line P. This line P. Now, this line, you are given the coordinates, so you can be able to find its gradients. So the gradient of AB, if gradient M of AB, of the line AB, gradient, let's say gradient of AB, I can't find my eraser, okay, gradient of line AB is equals to M. So how do we find the gradient of line P? We know this is not something we are going to prove, we just state it here, that when two lines are perpendicular, the product of their gradients must be equal to -1. So if if the gradient of line P, gradient of line P is now M prime. The gradient of line P is M prime. For instance. So because these two lines are perpendicular to each other, we can now say that the gradients, the product of their gradients, m times m prime must be equals to minus 1. We don't prove this, but take it for granted. The product of the two gradients of these lines is minus 1. If these lines were parallel to each other, their gradients would just be the same. Parallel lines, they have the same gradient. But when they are perpendicular to each other, the product of their gradient is minus 1. So these are the things you need for now. Then we try to solve some problems. Then you see how we use this idea. Let's look at one problem here. Find the midpoint of the line segments joining each pair of points. Find the midpoint of the line segments joining 4, 2, 6, 8, 4, 2, and 6, 8. Find the midpoint. They're asked to find the midpoints. Of this line segment. Say this was A and this is B. Now how do we find the midpoint here? So midpoint is just equals, now this is xy, xy, xy. Yeah? So this is your x1, y1, x2, y2. This is how you do them. You're adding x's. So now you have x1 plus x2, which is the same as x1, which is 4, plus 6, which is 10. And you have y1 plus y2. This is 2 plus 8, which is 10. So now midpoint is equals to x1 plus 10 all over 2, comma 10 all over 2, which is 5, 5. So that's the midpoint of this line segment. This is your midpoint, 5, 5. It's easy. This is just adding and dividing by 2. And the next one you are given minus 6, 4 and 6, minus 4. Number 2, you are given minus 6, 4 and 6, minus 4. You have to find the midpoint. Again, this one will just work it straight away. Midpoint here, we know is minus 6 plus 6, x and x, x1, x2, minus 6 plus 6 all over 2. And then you have 4 plus minus 4, 4 plus minus 4 all over 2. What do you get? This equals minus 6. This is 0, this again is 0. So I don't know what sort of line is this. It passes through the origin. So this line, its midpoint passes through the origin. That's what it means. If you have something, a graph like this, let me take out this one just to show you. If this is your graph and this is the line, so the midpoint of this line AB is going to be here, origin. That's the midpoint here, going to be here. That's what this figure tells you. I'm just making an example here. I don't know whether this minus 6 is here, but that is the picture anyway. Thank you for watching. Bye bye.